Imagine trying to understand a complex three-dimensional object from just a flat shadow. In machine learning, we face the same challenge, squeezing high-dimensional data into lower dimensions. Welcome to Principal Component Analysis. Suppose we have a dataset with three features, height, weight, and age, representing a three-dimensional cloud of points. Visualizing or processing this 3D data directly can be computationally expensive and overwhelming. To analyze it effectively, we need a smart way to project this 3D cloud onto a flat 2D screen without losing the crucial relationships and patterns hidden within. To squeeze this cloud onto a 2D page, PCA searches for new axes called principal components. It starts by finding a single line, the first principal component, that goes straight through the center of the data. This line is chosen specifically because the data points are most spread out along it, meaning it preserves the maximum possible variance of the original dataset. How does the math define this perfect line? It rotates a candidate axis and projects each data point perpendicularly onto it. PCA calculates the variance of these projected points. When the perpendicular projection distances are minimized, the variance along the axis is maximized. The direction of this axis is called an eigenvector, and its length, the eigenvalue, measures the variance explained. Once the first principal component is found, PCA looks for a second line perpendicular to the first, capturing the next highest variance. Together, these two perpendicular axes form a flat 2D coordinate system. We project our entire 3D point cloud onto this 2D sheet, successfully squeezing our data while keeping its most important structures intact. PCA is a cornerstone of unsupervised learning. It reduces complexity, removes noise, and makes high-dimensional datasets easy to visualize. However, because the new principal components are mixtures of your original features, we trade away direct interpretability for this massive gain in simplicity. Squeeze your data, but remember what you leave behind.